Yeah, somebody reported these replays saying, they were desyncing with their friend in this matchup in particular, Ices versus Peach. I've already looked at them a little bit. I've confirmed that they do appear to be real replays, but I kind of wanted to talk through the process a little bit just to show kind of like how I debug the desyncs, because it might be useful, for some other people to see how I do it, because it doesn't necessarily have to be me doing it. All the tools are available for anyone to look into maybe why there's a desync happening or something. Also, this will end up on YouTube, so if you're on YouTube, hello, welcome. Hopefully this ends up being fun and informative. All right, so let's get started. The first step is to determine whether this is actually a real desync. So I want to make sure, I want to basically rule out a situation where somebody was like using a custom ISO or skins or some kind of crazy thing like that, which caused the desync, right? So in order to do that, I basically want to reproduce the desync in the Slippy playback engine. So that is what we're going to try to do. So let us start. Okay, so the first thing to do is to try to play back the replays, but we're going to play them back in a very specific way. Now you'll notice that here I have 3 replays and Ices 1 and Peach 1 are each the same replay, just from the different perspectives. This is very important when you're trying to debug desyncs, because you want one from each player, because you want to see what happened to them. Because what happened to each player is different. That's kind of the whole point of a desync. Let's set it up so that we can watch these in a way that we can then tell if it was a real desync. The first thing to do is to open the launcher. Opened it. I am gonna go to playback here, and I'm gonna click open containing folder. This will open sort of the location where it sort of manages this Dolphin instance for you. And now we're gonna do a few things. The first thing we're gonna do is we're gonna make this Slippy directory in here. And then we're gonna make 2 text files. And we'll call this one playback, call this one playback 2. And now what you need to do is you need to go to Project Slippy GitHub and to the wiki and the Dolphin com file spec. Now this is the page that basically tells you how to define this JSON file, which instructs the playback Dolphin in what replay to play, and also what settings to play it with. So like how it's gonna basically end up being shown on screen. So we have a few important flags here. We have this should resync flag, which we're gonna use, and basically this tells it whether or not it should like look at the game state and try to make it match. And this is like basically Slippy's resync logic, and why sometimes on a stream you'll see things get weird for a little bit, and then all of a sudden they'll be back to normal. It's because the game actually did desync and playback, but the resync engine sort of is like, no, that's wrong, and then it tries to like force it to come back to what it should be, which we don't want here, because we want to see how the 2 replays differ using just inputs, basically how they would differ for the players in reality. We're going to want to turn this off. The other thing we're going to turn on, at least to start, is this rollback display method, which will actually play back the replay while also playing back the rollback frames. And this is important because rollbacks can be a cause of desyncs, and so you want to be able to, when you're watching the replay, play it back the same way the person actually played it, which was like the rollback engine kicks in and runs a few frames and stuff. It's very likely I won't solve it tonight, but hopefully we can at least make some progress and try to figure out maybe what's going on. We're going to copy this example. Oh, I spelled examp wrong. Okay, we're going to copy this exampay into our file. So I'm going to edit that file, I'm going to copy it, and then I'm going to do the same with this one. We got both of our playback.txt files loaded with like sort of the default data. Now I was saying before that we want the resync off, and we actually will want the rollback display method set to, you can see the different options here. There's normal, visible, and auth. And we want it to be normal, which will make it run exactly like when you're playing online, which means that the rollback frames won't actually be visible. They'll be like fast forwarded in the background. So we have our 2 playback files set up now. We got normal rollback display method, and should resync false. So that's what we want. what I'm going to do is I want to set it up so that I can play both replays at the same time so that we can kind of see like where they start to desync. So I'm going to set these two files up to load different files, one from each player. So let's do that. So the playback.txt, we're going to set the path to one of the files here. Make sure you use the double backslash if you're on Windows. I think / also works actually, but since it already fucking copies and pastes in with a backslash, I find it easier to just add an extra backslash. So here we'll grab Icy's 1 for this one, and then this one will be Peach 1. Okay, so I have the two playback files now. Now what I need to do is I need to make dolphins that will open them. I want one dolphin that will open the playback.txt, and I want a different dolphin that will open the playback2.txt. So what I'm going to do is I'm going to create a shortcut of this. Now, your default dolphin instance, if it's a playback instance, will automatically grab the slippy/playback.txt. So I shouldn't need to modify that. But this one will be, I'll call it like playback2. Now I'm going to go to properties and I'm going to add a flag. So I'm going to add a flag -i, which specifies the path of an input file, playback2.txt. And I'm going to hit apply, and then I'm going to open this, and then I'm going to open this. So now in theory, one of these should be one of the replays, and one of them should be the other perspective. Okay, so now what I'm going to do is I'm just going to open Melee. I'm going to start Melee on both of these. And like I said, in theory, they should both run two different replays, but really it's the same game from two different perspectives. So let's see. Okay. So these appear to be the same game, so that's good. You guys saw that, right? One of them was different? Yeah. Okay. So by doing that, we've basically confirmed that this is a real desync. We're running on a vanilla ISO. We're running the same inputs they were running when they played this game. And basically, we got the same result they did, which is it desynced. So it's not because of one of their skins or anything like that. If it was because of a skin, they would have desynced when they played. But when we played both of these back, they would have been the same. Now, another thing I can do here is I can change this to rollback display method off. Now, what this is going to do is it's going to let me play the replays again, but this time without the rollbacks, without the rollback frames running and the fast forward or whatever. So what that means is that we'll see if the rollback system is the cause of the desync. So if I just stop these and I start the game again after having saved this to off. Also, we'll just double check to make sure off is the right value, and it is. Rollback display method off. We just hit play again. Actually, I will skip ahead because I know that we'll be able to see it here, I think. So we're gonna go over here and we're gonna go to this frame. Okay, so we're on the same frame right now. On both. There's a reason for that. Can you guys see a difference right now? This is the same frame, so it is already desynced. And you'll notice that Nana's not in the same position. You can the easiest way to see it is the hammer. You see how the hammer in this one covers this background element, and this one it doesn't? So yeah, so if we advance each one at a time, so here the cleat is like under the stock, but here the cleat is still over the stock. And then this frame, this frame, this frame, this frame. This one gets hit. That one doesn't. The Peach is the same. The difference, the desync is in Nana's position. So the desync is somehow caused by Nana, or Nana's position. So basically what that means is we have to figure out why Nana is in a different position. So you can actually try to go back a little bit to see what happened in like kind of the previous interaction, right? Here they're like way on top. Let's see if there's a are we desynced at this point already? Let's see. This frame looks really similar still, right? So far to me, it looks kind of the same. So we have contact. We have contact. Still looks very similar. I think they're desynced, right? Yeah, I'm looking at this cloud and the hammer, and it's not the same. I wonder if somehow the input for Nana is different. Yeah, somebody mentioned Nana's DI. It's like, if the camera angle is different, then that means it desynced anyway. It's the same regardless. Because if it's not desynced, the camera will be the same. Yeah, so I mean, it's this throw. Okay, now I'm gonna do the method I was talking about before. So I have this script that runs through all the frame data and compares the states, like the character positions and stuff, to each other, and it will output sort of the first frames where things are different. What we're gonna try to do now is try to figure out sort of the first frame where it desyncs. So to do that, I'm gonna use a script which is part of the Project Slippy directory. There's a script called compare replays. So people are saying, you know, TDI or DI or whatever, right? What the script will do is it'll like basically scan all of the inputs for each player and it'll compare them, and then it'll tell me if the inputs are different for the same frame. It checks character position as well. The problem with this script, oh geez. So now what I'm going to do is I'm going to scan the replays themselves for differences, for desyncs. Now this script is already set up at the top to open the 2 replays in question, and it's going to print the first 5 frames that are different, and it'll tell me what info was different. So you can ignore these. This is like stuff at the start of the game that's irrelevant. So the first frame where it detects something different is actually this frame, which is the timer would be like 7:16.5. I've done this before, and this is actually not the first frame that things are different. And the reason is this script doesn't account for Nana. So I might actually try to change this script real quick to see if I can make it consider Nana as well. So we're going to try to do that. I do think the AI inputs do get written to the player block, even if it's a CPU. And if so, we will be able to see it. But I'm not 100% sure. And yes, ICs make everything harder. It's just like, for programming perspectives, it's just such a pain in the ass. Because there's like 2 fucking characters that you have to worry about. And Zelda and Sheik also makes things weird sometimes, but not as bad as ICs. Also, in the future, no one will have to do this because I'm going to commit the changes to this code so it'll handle ICs better. I think this is my first time really debugging an ICs, perhaps IC-specific desync. It would be interesting if it was some interaction between Peach and ICs. Someone did mention something about, I guess, throws that can be DI'd or throws that have special properties. Maybe Peach's throw has a special property which somehow interferes in some way. Okay, let's run it again. So, do you guys remember the time? I think it was 7:16.5, the earliest desync last time, right? See if we get one earlier this time. Yeah, this is earlier, right? And here you go. We have different inputs somehow. These don't matter. These are during like the freeze frames or whatever. Well, this is kind of wild. So you can see here, this is when the position is different. So we can go to this frame. So this is 18.15. Okay, so the crazy part though is that like Nana's inputs are not different at any point in the game. Like, cause it would show up in the script. It's only different specifically on these frames, which is pretty wild. Yeah, the input's only different for 3 frames. So you can see after these 3 frames where Nana's inputs are different. After that, the desyncs are just positions. Like now the positions are different. And the positions will be the only thing that are different for a little bit until Nana gets hit, and then there'll be more stuff. It wouldn't be late though, because in theory, both things should be happening exactly at the same time. Another crazy thing about this is it's not rollback related, which makes it even crazier, because I have no idea what decided this. Is it because like maybe the inputs were different on these frames or something? That's the only thing that's been different, right? I mean, that's something I can do maybe, is I can maybe change one of these replays so that these inputs are the same. I mean, I have no idea. It could be some bug. It wouldn't surprise me if there was like some kind of bug that caused inputs to be... Because I think these inputs are different because of some bug. But it usually doesn't matter. I'm gonna message Uncle Punch, see if he wants to join. Maybe he has some crazy insight as to how Nana works. Why would the game be the same for so long? All of a sudden, Nana decides to have a different input. I mean, it could be RNG. Maybe it could be RNG. Oftentimes, I would blame cosmic rays, but the fact that I can reproduce it in the replay every time means that there is actually something going on here. Once you've sort of figured out the root, I guess, or like what is really happening, the first thing that's happening that's different, in this case it's Nana's inputs, you have to start making some theories about why it might be, and / or trying to figure out how you're gonna determine how those inputs were different. So one thing I can do, and so this is where I'm like trying to think of ideas of things to try, is I could run these replays in debug mode, and I could sort of maybe put like a memory breakpoint on Nana's inputs and get to this frame and then try to figure out where it's being written in the code base, so I can see like what line of code is running differently, and then I can maybe go back from there to figure out why it's running differently. That's one idea. Another idea is I could try to fix this crap. Basically make it so the inputs are all the same on the first few frames, just to rule that out. I just feel though that if I do that, the replays become basically identical, right? But I don't know. I mean, who knows? So yeah, I'm currently trying to think of how I'm going to do it. I think one thing I can do, I guess, is I can modify the playback code itself to break when it reaches the frame in question. So at least I can get to the frame in question more easily. But I don't know how I'm going to do the memory breakpoint. Wait, these inputs are in the replay itself, and they overwrite what's happening. So of course the replays are going to play back differently. No, it wouldn't be caused by a drop packet. If drop packets could cause desyncs like that, then they would happen all the time. Drop packets might cause a stall, but it shouldn't cause a desync like this. Yeah, so I'm realizing that the replay itself is literally overwriting the inputs, because that's how it works. I really wonder what would happen if I don't overwrite the follower inputs. I might try to do that. I might try to change the playback engine to not overwrite the followers inputs and see what happens. In theory, Nana's inputs should all be like calculated on the fly, right? So even if I don't overwrite Nana's inputs, the replay shouldn't desync. So what I'm actually going to do, which is crazy, I am going to do a compare with immediate R21, and then if it's equal to 1, we're going to branch to injection exit, which means that for followers, we're not going to do anything. We're checking to see if it's a follower, and if so, we're not going to do anything, so we're not going to update the inputs. And then I'm going to grab these files. Technically, I only need this one. And then I'm going to go back to where that dolphin instance that I'm using is. And I'm going to overwrite the codes to use the new one that I just built. And I'll back up the old one. So now in theory, these replays will run without overwriting Nana's inputs. So it's here. You guys saw that? It's not desyncing anymore with what I just did. And it's actually going to play back the same way it played back on one of the instances. So I'm starting to think it actually might be related to rollback, and maybe related to fast forward. And the reason why it wasn't like that in the replay was because it was just overwriting the inputs with what was saved in the file anyway. Oh yeah, right, that's a great idea. So that means that now I can play back one with rollbacks and one without and see if... Yeah, okay, so now they should play back differently if I play them with rollbacks, because I'm not overwriting Nana's inputs. So this is the baseline. It's where Nana doesn't get hit. So if I go to back here and I do rollback display method normal, so I'm about to play them back with rollback display method normal again. And what we should see is, I think now we're gonna see them be different, whereas they aren't when I have rollback display method off. Maybe there's some special property about Peach's grab too that makes it happen, because I don't think this happens against like every character with ICs. Okay, so what I'm expecting is I'm expecting a desync here. I might not get a desync. They look to be in the same position to me. Yeah, they're the same. Wait, now they get... Excuse me? Now they get hit on both. So if I have rollback display method on or off, both of them don't get hit. If I have rollback display method normal, both of them do get hit, which isn't what I expected. I expected if I did rollback display method normal, one of them would get hit and one wouldn't. This one gets hit. This one gets hit. Has there only been one occurrence of this desync? There's actually, this person provided 3 replays. So that's one thing I can do. I can look at another one of the replays and see what happens there. Let's do that. Let's just take a look at least with the script. Okay, so this one's similar. This one is at timer 6 minutes, so later in the game. And this time the input is minus 0.75. It's again for 3 frames. Let's see if there's a grab. So it's interesting though that it's once again, it's very similar. It's for 3 frames and then all of a sudden the position's different. So I'm guessing it's gonna be a very similar situation, probably forward throw. So let's take a look. Let's set it back to the normal code set so that we can just like see both at the same time with seek. We got a grab on Nano. I think forward throw starting, and then right during the hit, 99, the second place you see the hit, we probably have a desync here already. All right, here's our forward throw, and we're gonna go to the same frame, 7-2-11, and yeah, you can see Nana's a little bit different position. Anyway, we have a desync here, very similar to the first one. Let's look at the third, just to make sure. I'm assuming it's gonna be almost exactly the same. So replay 3. Yep, 3 frames of a different input, and then the position's different. So it's probably on that forward throw release again. This is frame 1390. I see her gearing up for a forward throw. You guys see that? She's gearing up for it. Yeah, there it is. Okay, here she misses a tech, and then on this one, she just lands. It's gonna be a fun time, everybody. Here we go. Now we're gonna get really in the nitty gritty. I don't know how fun this is gonna be, but we'll try to keep it fun, I guess. Well, the thing is, I'm not too interested about Peach's throw mechanics right now. I mean, I think it's interesting as a concept, but what I care more about is why Nana's inputs are different. Because to me, that's the problem. Like, I don't, like, Peach's throw might be partially what causes this to happen to some extent, but I'm not too interested in the mechanics of why the desync happens in terms of Peach's throw. What I'm more interested in is why this input is different. Because what I want to do is I want to trace back this input to see what data, ideally if this is possible, it might be too deep, but I want to trace it back to see what data this input depends on. And if I can do that, I can try to figure out if it's similar to Fox's tail, where like it's dependent on data that's calculated during the fast forward or some crazy thing like that. And that's why it's different on the 2 different clients. Yeah, so in 2 of the replays, Nana holds halfway down, and in 1 of the replays, Nana holds 3/4 of the way down. But for the other person, it's always 0. Okay, so the first thing I want to do is I want to go to this address and breakpoint. So now, in theory, it should break. Cool. So it broke on before frame 1390 shows up. Okay, let's add some breakpoints. So I've got a breakpoint before the frame that we care about. Now I'm gonna breakpoint this stuff, which is stuff that these are addresses Meta gave me. So let's see how that goes. View breakpoints. Dude, this UI is so garbage. Nothing happened when I did that, but it's here. Okay, so before I was digging into what was happening with Nana's inputs, and they're definitely different with no rollbacks and normal rollbacks for the same replay. Nana misses a tech, and I'm assuming in this one Nana lands or jumps? Jumps. Okay, so something else I'm curious about. This is the part where I was saying earlier, probably, I don't know how interesting it's going to be because I'm just kind of digging deep. I'm starting to dig deep into the code and like what's different under different circumstances, and I'm going to try to trace back what's causing that difference. No, did I lose all my breakpoints? Ah. The input for the CPU is being overwritten by Slippy. The way I'm reproducing different values right now is I'm switching from rollback display method normal and rollback display method off. That causes different results. That's what I was logging before. I logged the values at these lines. So for example, this is the IC's 3 replay with no rollbacks. These are lines that Meta fetched for me that seems to be related to CPU analog inputs. And when I have it set to off, I get these values at these lines. And then when I have it set to normal, I get these values at these lines. The desync in the normal reply is because Slippy is... Yeah, I wouldn't say it's correcting it so much as like if you look at the replay files themselves, like if you look here in specific on these frames, one replay file says set the joystick Y value for Nana on this frame to 0, and then one of them says set the joystick Y value of Nana on this frame to 0.5. So remember, our logic for playback, it goes through every player and it overwrites the analog values. So that's what causes it to look desynced when you have it set to off or whatever. But what I'm digging into is I can still make the game calculate different values by messing with this. So I'm experimenting with having this, like changing this value from off to normal and seeing the difference in those scenarios. So in restore game frame.asm, I added this line, these two lines here, which basically they check to see if the current player is a follower. And if the current player is a follower, I just exit restore game frame. So I made it not overwrite the inputs in the player block, in the whatever, the character block for followers, so that I could debug this more effectively. But even if you left this and you just looked at the CPU analog inputs and you change this from off to on or whatever, or off to normal, you'd still get a difference in the CPU's calculated values. It's just that it would be overwritten by this logic, and then it wouldn't necessarily matter for the game itself. I can give you a high-level idea of what I think is happening, but it's not very specific yet, because that's what we're digging into. But I mean, that's what we're trying to figure out. I think at a high level, what's happening is the fast-forward logic or the rollback logic is somehow interfering with how Nana is deciding to react in a given situation. So we're trying to figure out the details around that so that we can fix it. Okay, what do I want to do next? I think what I want to do next is I'm gonna go back to normal, or off rather. Yeah, it's when you f-throw Nana. So right here, breakpoints, load. So here I don't care about this. This I do care about. Where does it load this from? Is it possible that maybe our rollback breakpoints aren't fetching everything that's used for like CPU calculations, so that when we roll back, things can happen differently? That's a possible theory, but I don't know. Is R28 not supposed to be an address? Oh, is that an ID? Oh, it is storing a byte. Oh, geez. Is this just a melee bug? But you said this happens with rollbacks off, right? That would be, like, I'd be more likely to believe this was rollbacks on, right? Because that would be the one that would be fucking with memory a lot more. But rollbacks off doesn't really fuck with memory at all. I mean, my current best theory is that when I ran a bunch of games to try to figure out what memory addresses I needed for the backup, for the save state, maybe I just never ran into this case, which seems to be a pretty rare case, and maybe it uses some memory that normally isn't used, and maybe I excluded it from the backup because I didn't think it needed to be part of the backup. I mean, that's definitely one possibility. I'm so confused. This is wild. I'm in the same place, and it's storing, yeah, it's storing this value, which is just a memory address, to the value that's going to be read to determine the input. That's fucking wild. Is it possible it's a vanilla bug? I mean, this would explain why you can get different behavior, maybe. to some extent, right? Because, I don't know, there's no guarantee that these addresses are going to be the same on both clients. I don't know where this address is coming from, but to fix it, you change the code so that it's defined behavior instead of undefined behavior. Because see now this value it's loading from in R28 right here, it's going to be 40. And it's crazy because that value is different than what I was getting in other scenarios as well. Because now it's 40, but when I was reading it before, I was getting this. I was getting 0xa0. I wasn't getting 40. So, or 0x40 technically. It's really bizarre. Like, it just seems completely non-deterministic as it is right now. Super wild. Because, yeah, this is going to load. Was that what it was? Oh, because it loads the first... Wait a minute. Oh, here's 40. Alright, so I'm going to do a full look at what seems to be going on. I'll try to get into what Uncle Punch and Meta are talking about too. Basically, I'm going to add some breakpoints here because this is the frame I'm concerned with. And then I'm going to add a breakpoint here, I think. Yes, here. And then I'm going to add a breakpoint here. So something else that I'm curious about Meta is like, why does it write to this value? Why does it write to this memory location twice? So it's writing to R3, which is our value that we're going to load from. And it's writing a byte, and it's writing the byte in R27. So this one's actually a byte, right? Because this one's 80. But then here it overwrites. Oh wait, this is a different location. It's the 71D. When is 71D used though? Because now it's writing, and I have 0 here, but oh maybe, okay, it just like runs again. Okay, I think 71F is what it is, right? 71F, store byte, R28. And it's this, so it's going to write 40 to it. So were you guys looking at where R28 comes from? Was that what you were saying? Because, yeah, R5, and then R5 is R30, and then is R30 never set? Yeah, I see it now. Comes from R30, and what's R30? I mean, here it's loading R30, which is garbage. No condition sets it. I see. So this input never gets set. I mean, it does look like there's some places where it gets set, but you're saying it's just skipping it all. So it never sets the value of R30, which means it's just garbage. It's coming from some other place, some other random parent or something. And then that value gets used for R28, and it's what is written to this value 80F0C71F, which we're going to see again, I think shortly, right here. R28 is, yeah, right here. So 80F0C71F, this is what we were looking at. And when this value gets loaded, it's 40, which was like the end of that address. So yeah, I mean, that's probably the reason why. I'm assuming that's not intended to some extent. Like, I don't think inputs that are unset ever get used like that as inputs to other functions. I mean, there's a stupid fix here, right? Potentially. Like, under this scenario where R30 never gets set, we just set it with like an RNG call or something. What's the priority of this? We should be, it's player think, CPU think, right? So we should be able to, yeah, I mean, the RNG is synced at this point. So in theory, if we just like, I mean, I'm not saying we have to do this, maybe there's a better fix, but certainly I think that would fix it. Like if we get to this condition, we just do an RNG, because it doesn't seem like it matters. We just like RNG the fucking input, and then both sides will get the same RNG instead of using a memory location, which might be different on both sides. What's the condition, Vin, that you're looking at where it doesn't set it? What's the line that's on? Is this the condition then that would skip it? That's true. We could just initialize R30 to 0. That might be simpler. Oh, this is where the condition. So this is the condition. This is the branch then, I'm guessing. Yeah, I mean, I'm assuming this loads data in order to do this compare, and then this is the branch, and if we follow this branch, I mean, it just has to skip this, right? Like, if ever this gets skipped, we're fucked. Because this is the only place where it gets loaded. I mean, we can't make any guarantees. I assume you want to keep looking into it, Vin, but do you think I should write a code real quick to just initialize R30? That's between -0.001. Do you know what those values are? Not yet. Okay. Well, obviously I'm curious, but do you think that just like initializing R30 is a acceptable fix? I don't know if I want to emergency deploy to fix it, but it'll give a nice conclusion for it for now, and then I can go to bed. Yeah, I mean, it might also end up being the correct permanent fix, but Obviously, you know, if we research it more, might find out more info, maybe find a better fix, I would guess. But it's possible this does end up being the best fix, I don't know. All right, well, I mean, I guess, I could just do this. I can copy address. We've already stored R30. Where's the dynamics fix? So I think one thing I can do to test, I think I can test this fix, because I can add this to the playback engine, and then I can try all the different permutations again and see if they all come up different or not. So I guess this goes in common. I guess, do I just make a new folder for like melee bug fixes? I guess I'll just call it Nana Determinism. Well, this turned out, I mean, I think desyncs always turn out like this, but this turned out to be extremely interesting. It's just like some really weird melee thing where melee is just doesn't appear to be deterministic in certain scenarios. We probably never noticed this in replays because in replays we always have the resync logic on, and the resync logic would probably be quick enough to prevent this from happening. Yeah, we aren't sure, but I think that seems to be the most likely case, in my opinion. Maybe bug isn't correct, but oversight, perhaps? I feel like you never want to use undefined values. So B8, 5B8, copy code line. All right, and now we're gonna do load immediate R30 0. Okay. I mean, certainly an option if it's a problem is go back to what I said, which is instead of initializing it to 0, we just assign a random value, and then it would be closer to how it behaves in reality, which is that like it's just kind of random based on whatever memory address. I mean, I'm not sure if that's better. I think it would more closely match the result of what was happening before. Okay, anyway, let's just try this. So I added this Nana determinism assembly thing, right? So now let's add that to our playback file. So we're just gonna add it to codes, general codes, Slippy playback. I guess we'll add it to Slippy playback, right? And type inject folder, source folder, commons / Nana is recursive, true. Annotation makes Nana inputs deterministic. Oh, did I spell it wrong? Determism. Sick. Thank you. So now we have that in our playback. So now let's build this. Okay, so that should have worked. It should be built now. We can double check by going to our codes and looking for Nana. Okay, so we have our code here, our Nana determinism code. Cool. So now let's stop this and let's run it and let's see what behavior we get. Let's see what result we get. I'm also gonna remove all these breakpoints. We don't need them right now. We probably have a temp fix. That's what I'm looking at right now. So I'm gonna fast forward to the forward throw right here. Nana lands. Okay, so Nana lands and then we have a game or whatever. This should be desynced already, right? I think this is I mean, I'm assuming this is desynced. Yeah, this is desynced. This has to be, right? Unless Peach. Yeah, the Peach is doing very strange things. So Nana landed. So what we gotta do now is we change the playback to normal, which before was causing different behavior, and we see what happens here. I kind of want to make it random though, Vin, just to better simulate what it did before. Okay, Nana landed again. So yeah, so at the very least, that wasn't any different in both cases. So before we made this change, we would get different behavior when we went to normal and when we went to off. And in this case, we did not get different behavior. So that might be a fix. So it does seem like this is probably a fix. I think we may look for a better fix, but it's pretty cool. Pretty cool.